You will see the recording, Umar.
Maybe he cannot use the mic.
Now?
Yeah, he cannot use the mic.
Okay.
Continue.
Okay. So creep temperature, as I told you, that if my temperature is greater than 0.4 times the melting temperature in Kelvin, then there will be a significant change in the shape of the creep graph, right? So if you see at at this temperature, at this let's say this is a Tm, this is something Tm, this is something, this is T1, this is part T2, and this is part T3. If you see that by increasing the temperature, well, T1 is greater than T2, which is greater than T3, right? Sorry, T3 is greater than T2, it is greater than T1. Okay, so at highest temperature, if you see that the creep graph is having a constant slope, right? And it is going to the fracture very soon, right? And on the other hand, if you see the at the low temperature, then the fracture point is here, right? So it means that the creep life become very short when you increase the temperature.
Yeah.
Okay, so for the secondary creep, we can say that the strain rate is constant at a given temperature and stress, right? And strain hardening is balanced by the recovery. So if we move, okay, so you see that there is a constant line, constant slope line, right? So constant slope means that the strain rate, strain hardening, strain hardening is balanced by the recovery. Okay, so this is the material, right? And there is some yielding occurring, right? There is
Right.
some yielding occur, and this yielding is balanced by the recovery. So if this is elastically deformed, right? Elastically deformed, so it means that it is regaining its original shape, right? And we can relate the strain rate by the help of these material, right? So here K2 is the material constant, N is what we call the stress exponent, right? It is also dependent on the material. Sigma is the applied stress, and QC is basically the activation energy needed for the creep. R is basically the constant, the what we call the ideal gas constant, and T is the temperature in Kelvin, right? Okay, so creep failure. If you microscopically examine the creep failure material, then you will see that there are some GV cavities, right?
Yeah.
Okay, so if I increase the stress, then these cavities will increase. Okay, so this equation is basically, okay, so L is the function of applied stress, right? So L is the life, and TR is the time to rupture, right? So time to rupture we can find from this help with the help of this graph, right? So time to rupture from here up to here, it is basically TR, right? Time to rupture. It is also written here. TR is this, right? And if I take the log and plus 20 multiply by the temperature, then I can find the life of the creep rupture, right? Okay, so for 2000 psi applied stress and at 800 degrees centigrade for S50 iron, this graph has been plotted, right? So
Right.
this graph has been plotted, and and it says that find the time to rupture, right? So if I, this is basically a problem for us. So if I convert this 800 degrees centigrade to Kelvin, how much is it? 800 plus 273. It comes out to be, how much is it, Hamza?
Yes.
800 plus 273.
1073.
Okay, so it is
Wait, I will
1000.
check.
Yeah, it is one. Okay, it is okay. 1073, and the applied stress is 2000 psi, right?
Yeah.
Okay. So when I plot against this, then I found out that the life of this material is 24 into 10 raised to the power 3 kilo hours, right?
Yes.
Kelvin into hour. So I use this equation and I put the value of L from this graph, right? And the T from this given data, right? And 20, and when I solve for the TR, then it comes out to be 233 hours, right? So it means that at these conditions, this applied stress and this, after 223 hours, the material will fail, right?
Yeah.
Okay, now this is this problem for us. Estimate the rupture time for S50 iron at, okay, so in the exam you will be given a graph like this, right? Hamza?
Yes, in the exam.
Yeah, in the exam you will be given a graph like this, right?
Yeah.
And you have to remember this equation, right? T into 20 plus log of TR is equal to L, right? So from the,
Yeah.
so you will check that this is 20 into 1000, so it is 20,000, and you will see that, okay, so if I go down here, right, in this graph, and I look down here, so it touches the 24 into 10 raised to the power 3, right? L.
Yeah.
So I found the value of L from this graph, L from graph. Okay, and I need to find this TR, right? And T I am given with this, and I will convert. I told you you will convert it to Kelvin, right? So can you convert it to Kelvin?
In Kelvin.
Yeah.
Wait. Uh, 1023.
Okay, so let me solve in this in the on the whiteboard, right? Okay, so can you see a whiteboard?
Yeah.
Okay, so it was T into 20 plus log of TR is equal to L, right? So L you should find from this graph, right? So you are given with the sigma is equal to 20,000 psi, and T was 750 degrees centigrade, right? Okay, so this is the graph of sigma and life, right? So this is a graph like this, and for the 20,000 value, you check it, and this touches the x-axis at 24 into 10 raised to the power 3, right? So L is 24 into 10 raised to the power 3 Kelvin hours, right? And temperature is 750, so it comes out to be 1023 Kelvin, right?
Yeah.
Okay. So now I need to find this TR. So if I given this 1023, okay. So 20 plus log of TR is equal to L. L is 24 into 10 raised to the power 3, right? Okay, so when you divide this 1023 by this 24 into 10 raised to the power 3, so how much is it? 20 plus log of TR is equal to 24 into 10 raised to the power 3 divided by 1. So how much is comes out to be?
Wait a second. It will be 23.5.
Into 10 raised to the power 3 or not?
Yeah.
Are you sure?
Exactly like that. Yeah.
Okay. So 20 plus log of TR is equal to this, right? Let me reply and divide by 1023. Okay, so now log of TR is equal to 23.5 minus 20, which comes out to be 23.
Again, doctor.
23.5 minus 20 is 3.5. Okay, so this is 3.5, right? And log of TR is equal to 3.5, right? So we are given with this log of TR is equal to 3.5. Okay, so how will you solve our TR now? Can you solve this equation?
How?
Hmm?
What does it mean, TR? How we get it?
Okay, so you solve this log and 3.5. How can you solve? TR is basically the creep time.
Yeah. Divide by log.
No. Okay, so you don't know how to solve this equation?
No.
Okay, so this is what we call the base 10 log, right?
It's log. Yeah.
Okay, and this is the base E log. This I write like this ln, right?
Yeah.
So this is base E log and this is base 10 log. So if I take the 10 power to the both side, log of TR is equal to 10 power 3.5, right? So this 10
Yeah,
and
right.
log 10 and log would cancel, right? So TR is equal to 10 power 3.5. So how much is it now?
Okay.
10 power 3.5 is
Wait. 3162.
31
62.
hours, right?
Yeah.
So this is the time required for rupture, right? This is TR. Okay, so do you remember do you understand this problem or not?
Yeah, we understood.
Okay, so okay, so if I see your mathematical concepts, okay, so if this equation was like this, let me write it a different color, and it was like ln of TR is equal to 3.5. So how will you solve it? No.
We put down 10.
What?
We put down 10 down the log
Yes.
and down the 3.5.
No. Okay, so now this is
Okay,
this.
Len.
Yeah, ln. So this is
Put E.
E. Yeah. Okay. So E ln TR is equal to E power 3.5. So these two will cancel and TR is equal to E power 3.5. Right?
Yeah, it will be 3.5. 33.
33.
Yeah.
Okay. But this is just for your understanding, right?
Yeah.
So now you understand.
Yeah.
Okay. Okay. So I hope you remember you learn this thing.
Yes.
Okay. So okay. So we have covered this, right? And this is the summary of this chapter, chapter 8. should I take a test from you in this chapter or not?
No problem.
You can study.
Not very well, but today, inshallah, we will study very well for chapter 8.
Yeah. Well, study it well, okay? Because it is very important for your exam.
Okay.
And
The doctor said chapter number 9, the most important for the final.
Okay, so chapter 9 we will study from tomorrow, inshallah, tomorrow. And can you discuss with Umar that we can take class every day, because it will be very good for you people to cover the material for the exam.
I will tell him.
And you also do not respond in the WhatsApp. So please, if I post a message in the WhatsApp, so please respond it, right?
Okay.
Please respond on WhatsApp. Okay, so this is the summary of chapter number 8. So chapter number 8, first of all, we said that the engineering materials are not as strong as predicted by the theory, right? And flaws acts as a stress concentration, right? They cause failure at the stress lower than theoretical stress. Okay, so you remember this equation, right?
Yeah.
And what was the value of KT? Right?
Yeah.
Okay, so short corners produce large stress and premature failure, right? While the blunt corners produces low stress concentration and non-mature failure, right? So failure type depends on the temperature and the loading, right? For simple fracture, non-cyclic, and T is less than, failure stress decreases with increasing in the flaw size, decreasing the temperature, and increasing the number of loads, right? And for fatigue cycle, the cycle to fail decreases as sigma increases, right?
Yeah, clear.
So if we increase the stress, then the cycles will be decreased. And for a creep, when the melting temperature times 0.4, the temperature, the operating temperature is greater than the 0.4 times Tm. And remember, Tm is always in Kelvin, right? So the time to rupture decreases as sigma or temperature increases, right? Beyond this point. So Tr, it means that Tr increases if we increase T, right? But T has to be greater than 0.4 times Tm, right? Okay. So chapter 9 is about phase diagrams, right? Hello?
Yeah.
Okay, so
Here.
phase diagram means that phase means liquid or solid, right? Liquid or solid or gas. Phase mean this, right? And diagram mean graph. Okay, so if I solidify a metal, right? So it will be liquid at some temperature. This is temperature and this is the concentration, right? So it will be liquid here. And when I decrease the temperature, then it will solidify here, right? It will start solidifying like this. Small crystal will form. And if I increase the decrease the temperature further, so it will become solid, right? So this is basically the motivation of this chapter, right? And we have to study it in detail, very detailed, right? And I will also try to form the notes of this class, right? For this chapter from tomorrow, inshallah. And then we can take class tomorrow at the same time, right?
Inshallah.